Okay, we're now going to look at fitting the Pulsar rotation drive. It's a remarkably simple operation, to be fair. We rely on 2 bolts on little standoffs on the wall. The main point is to get the drive at the right height and have it 90 degrees to the dome flange. So what we're going to start with doing is making sure the 2 thumb screws at the top are fairly loose, so we can get our drive and thread it up through the flange. Then what we want to do is just make sure that the top is parallel, the drive is roughly straight, the drive is as high as possible without any contact at the bottom, and we're just going to draw a pencil line to give us a rough height. Once we have that pencil line, we're going to come down and then we're going to take the front off the drive. These come assembled from the workshop. That's mainly to show how everything goes and that everything is complete. But we're just going to whip off these nylock nuts and washers. And take off the thumb screws. The thumb screws adjust the tension when the drive is in place. They don't need to be too tight, and we can tune them to the curvature of the drive, which you'll see shortly. We're going to unplug the 2 front wires of the front motor. Yellow is positive, green is negative. And lift the front away so we're left with the back plate. Then we're just going to take the standoffs off. Then we can hold our drive up, find our line and drill 2 8mm holes using the back plate as a guide. Once we have our holes drilled, we can then take our bolts, our 60mm M8 bolts, put them through, usually with the help of an assistant. Then we have a PTFE standoff, goes on, and then our plate will then mount from there. We do that both sides and just clamp the drive top off with the long nut. Let's get the other bolt through. Drop it. Once we've snugged these bolts up, we then make sure our springs are in place. We get the front of our drive and remount it with a washer and a thumb screw at the top. It's worth mentioning at this point, the drive will only fit on the larger side panels. It isn't designed to go on the door panel or the rear panel, and you can just eyeball to get an idea of the curve. There's no exact point to fit it. It's just important to get the height as high as you can without being too high. Once we have our bolts on, we can then plug our motor back in, and we can then power the drive and check operation, which we'll do shortly. Now that we have the drive bolted in place, I've applied the 12-volt power supply as supplied, and we're just going to test the operation of the drive. So currently our thumb screws are very loose where we've just reassembled. So it won't grip the dome fully. So we're just going to nip them up slightly. They don't need a lot of tension. And you see now we're running the dome nice and smoothly. Often with the fresh install, we will revisit this after a little while because the dome often takes a little bit of time to settle into its final form. But now we know that the dome runs on the drive, the next operation will be fit the encoder and the home sensor for calibration. Okay, the next part of the operation is fitting the encoder. The encoder is a very simple device. We have a rotational counter, and in here we have a magnetic sensor for the home position that we'll come to later. So what we're going to do is mount the encoder on the wall so it's in permanent contact with the dome flange. Obviously we have a pre-drilled hole currently because this is a workshop dome, but we want to get the encoder as high as we can without touching the top of the wall. So once we're happy and you can eyeball it, we're going to drill an 8mm hole and then we're going to bolt the encoder to the wall. Now, depending on where you put your encoder, will depend on whether you need to space it with a nut or not. But also, these are sprung steel. They're designed to be bent slightly as a spring to enable good contact. So we're going to bolt it onto the wall and then we'll move on to fitting the encoder magnet. Okay, we've bolted our encoder in place, making sure it's roughly straight. We've plugged it in using the supplied cable. A couple of quick tests we do before going any further. We make sure that the encoder is in good contact with the dome flange. We can do that by gently pushing and letting it pop back so that we know that that spring is pushing it hard against the flange without too much tension. And then we can move the observatory using the left and right buttons, and we can see that the degree readout changes, so we know that it's counting. The next stage will be decide where to put our home position and then fit the encoder magnet. Okay, we fitted our encoder, we verified that it counts and works. The next thing to think about is a home position. Typically, we try and line the home position up with north. That just makes automation a tad easier. It's also nice in this instance, we try and line the aperture up with the door or one of the panels just for aesthetics. So we're going to set our home position where we want it. We're then going to mark the dome just above the encoder with a pencil, and then we're going to move the dome away slightly to give us access to drill a hole. Okay, we drilled our hole with a 10mm drill bit. You'll notice that the hole is very close to the bottom of the dome flange. That's absolutely fine, that's where we want it. We want it as low as we can get it so that the magnet has a good chance of picking up the sensor. The next stage will be to insert our magnet and then we can calibrate the dome. Okay, we've drilled our hole denoting our home position. We're just going to insert our magnet. There's a yellow sticker on the magnet which goes into the dome. Now, quite often it's worth just securing with a bit of tape just to stop the magnet from popping out. Okay, we've put our magnet in. I've just covered ours with a little bit of tape just for security. And now we're going to verify that the magnet is read by the sensor. So we're going to go into the menu, we're going to go to settings, okay, and then you'll see there's an option for test. What we have here on the test screen is the number may be large, may be small, but that's the raw encoder readout. It's not a degree or anything, it's the raw encoder figure. And we have a circle, which is currently shaded in. If I move the dome, you'll see the number changes. And that tells us that the encoder is reading the movement of the observatory. This circle denotes the magnet, and we shall see that when we put the magnet over the encoder, it changes state. So that tells us that the home sensor is now working. Next operation will be to calibrate the dome. And to do so, we're just going to go back into settings, scroll up to calibrate and hit OK. The dome will then do its calibration. Okay, once it's run through its calibration procedure, we can then verify home. The calibration procedure is automatic, so what it will do is it will measure the diameter of the dome itself so that it knows how far 360 is and it knows its home position in regard to the magnet. From here, we have a position where we can then automate the dome later on, and we can also set up some other functions. Now that we have our home position set, everything is good to go. The final operation we have is to set up the induction charger for the shutter drive if you have one. So the first part will be to fit the first induction plate to the top of the rotation drive. Okay, we fitted our top induction plate for the rotation drive. The final operation is the second plate that goes on the dome top for the shutter. We're going to set the dome to the home position, verify that it's at home, and you can do this by moving it away, telling it to go back home. Once it's reached its home position, we just offer the two plates up, ensuring there's a gap between 2 and 6 mil between the plates, and drill a 6 mil hole where the bracket meets. We then bolt it to the dome top. Then we can plug our plate into the shutter drive and into the rotation drive, and we're ready to charge.